and welcome. My name is Hayden Fowles from fowlesonfantasy.com, and today we are going to be looking at screen space reflections in Blender 2.8 in the Eevee engine. In Blender 2.8, there are a couple of methods of creating reflections. The first one being light probes, another being screen space reflections. Screen space reflections has the advantage of being real-time as well as more accurate, as well as being able to animate objects and see that animation update in the reflection, but it also has a few downsides that I will show you in the course of this video. For the purposes of demonstrating screen space reflections, I'm going to create a sphere, which I will use to demonstrate the screen space reflections on a curved surface. And then I'll also create a plane to demonstrate screen space reflections on a planar surface. To initialize the setup of a scene that uses screen space reflections, we're going to go into the Render tab, and then we're going to see that there is a checkbox aptly named Screen Space Reflections, and we're going to make sure to check this. Within that checkbox, there is a number of list of options and other checkboxes, but we will deal with those at a later stage in this tutorial. So right now, we just have to make sure that that checkbox is checked. Now, we're going to want to go into our shading workspace, and I'm going to demonstrate the different ways that you can enable your material to make use of screen space reflection. I'm going to change the view from a look div view to a rendered view by pressing Shift Z, and then I'm going to select the sphere and create a new material. Now with this new material, I'm going to show you how the default setup that you're given can be used to generate a reflective surface. So the default setup is a principled BSDF shader connected to the surface of the output. The principled BSDF shader is a combination of a lot of other shaders, so you could call it a uber shader or an ultimate shader. Now the value that we're going to be most interested in is the metallic value. The metallic value is telling the material to be either fully reflective or completely non-reflective. By increasing the value to 1, we'll see a noticeable difference in the rendered viewport. Now, when we move our cube, we'll see that there is a slight reflection in the sphere. Now the reason why it's so grainy is because of our roughness value. So if we decrease our roughness value, the image is going to be a lot clearer. So let's decrease it to 0. And as you can see, as I reduce it, the reflection in the sphere becomes a lot more crisp. We can even make out the cube as we move it in the viewport. Even our plane is visible. So, our reflection is working, but we are a long way from done. Let us make this reflection a bit nicer. So let's go back to our Render tab and go to our drop down of our screen space reflections, and let's increase the trace precision. Turn on refraction and turn off half res trace. What half res trace does, it essentially does what it says. It traces half the available information that it would otherwise. This will seriously reduce the quality of the image, but it will also exponentially increase the optimization of the scene. So if you've got a computer that may struggle with this type of scene, you may want to keep this checked on. And what I mean by that is if you have a scene with a lot of reflectivity going on, then that's when your computer might start to see a struggle. But for one reflective surface, this shouldn't be a problem. But there we go, as we turn that off, you can notice that the reflection is much crisper than it was. So I'll just turn it back on, and you see how it gets all fuzzy and ugly. But keeping that off makes it nice and crisp. For now, you can keep most of the other options the same. However, I do encourage that you play around with these settings, as experimentation is often one of the best ways of learning. Now that we have our reflective surface, we can do so much with it. We can even change its color. We can also change how much of it is reflective based on a metallic map. I'll go into creating a realistic metallic texture in a later tutorial. But for now, let's create a new material on the planar surface, and I'm going to show you another method of getting that screen space reflectivity working. and that's by using the glossy BSDF shader. The glossy shader, just like the metallic slider from the principal BSDF shader, affects how reflective our material is. However, instead of glossiness or reflectivity being a slider, the only slider that we're giving it is roughness. So the less rough something is, the more reflective it will be because light is scattered less. So you see, as I reduce that number close to 0, the reflective image becomes a lot more sharp. Also, we can see one of the main pitfalls of using screen space reflections for planar surfaces. You may notice that the reflection isn't accurate as to what is, well, what our minds perceives should be reflected, in this case, the blue sphere and the cube. Instead, what we're seeing is the background. And it doesn't matter what we do, to the best of my knowledge, but using screen space reflections will only result in this effect. Even if we change it out to a principled BSDF, it won't change the fact that because of the limitations of screen space rendering, we're not going to get the result that we desire. Instead, we have to do something different. But before I do that, I would like to show you more in depth how exactly screen space reflection is working, so as to give you a better understanding when you go off and make your own projects that may include screen space reflections. I will demonstrate it with a plane. So let me just scale it up and rotate it 90 degrees on the x-axis and just bring it back in y space. Now, as you can see, it should be reflecting, however, there is no reflection. Let me change its color so that it is easier to show you as to why this is the case. As I push this plane closer and closer to the reflective surface, you may have seen the slight blue outline. Now, let me rotate this at an oblique angle and then push it closer. So as I do this, you'll see that we can see the reflection as we would expect it to look like. And this is because we can see what it is reflecting. You may notice that where our cube occludes our blue surface, it is also occluded on the reflective surface. And this is the crux of how screen space reflections work in Blender. A good rule of thumb with screen space reflections is if you cannot see it, neither can the reflective surface. And that is exactly what's going on here. We cannot see on the other side of the sphere or the cube, so neither can the screen space reflection. So it's impossible for them to be calculated, because that's just not how it works. Unlike Cycles that uses ray tracing, which gives us this result, Eevee does not use such a technique. So it's not going to be the same sort of reflection, it's more trickery than anything else. And that is why it is better to use screen space reflections as a standalone on curved surfaces like the sphere rather than a planar surface, because when we're looking at a planar surface, we are often behind the object that's going to be reflected off of it. Now I'll show you how to get around that. So I've opened a new document and this is the default scene setup. The first thing that we're going to do is create a plane, and we're going to drag that in Y space and rotate it by 90 degrees on the X axis so that its surface is going to be facing our cube. Then let's go into our shading workspace and create a new material for our plane, and we'll call this mirror, and we'll just increase our metallic and reduce our roughness. And now I'll change it from a look dev to a rendered viewport. And the next thing we're going to add is a light probe, more specifically the reflection plane. Then I'm just going to rotate that on its x-axis and do the same thing that I did with the plane. Just stretch it out and push it back in Y space, and straight away you're going to notice something. You're going to notice that our cube is reflected in that reflection plane. But if I were to render this out right now, nothing would show up as a reflection. You can't see the cube there, but we can see it. This is the rendered viewport. So what's going on here? Well, it's actually quite simple. What we have to do is we have to select our plane reflection, and then what we're going to do with it is we are going to push it back so that its bounding box is covering our surface that we want to act as our reflective mirror. And now that we've rendered it out, voila, we have a reflection. And it's reflecting the side of the cube that we cannot see, so we have mitigated the downside of using just screen space reflections. Now if we go and turn on screen space reflections again and render this, we'll see that we are given a bit more of a precise outcome, but unlike before when the faces on the far side of the cube were not rendered, they are now. So we can use both the plane reflection and screen space reflections in conjunction with one another to make sure that we have all our bases covered. So for recap, we're not going to use screen space reflections for a planar surface because it won't work. Instead, we're going to use a plane reflection light probe. However, you can use just screen space reflections for a curved surface like a sphere. And lastly, if you cannot see it, neither can the reflective surface with the screen space surface one. And alas, that brings us to the end of this tutorial. And as always, if you've learnt something or have enjoyed my video, please give it a like. And if you'd like to see more videos like this in the future, please consider subscribing to my channel and hitting that bell button. Thank you so much. My name is Hayden Falzon from falzonfantasy.com, signing off.